Hi, welcome back. So we will we will begin the second part of this week's course recording. So we have just talked about the discussion board assignment, which will ask you to make a record in DC format to describe this article and then discuss these two questions. So you will need to post this assignment to our discussion board. And I should also say that this assignment will be worth 5 points as part of the discussion facilitation grade in our overall grade. So that is the assignment. But what you will notice from the DC generator that I just showed you here, so the output, so this is the output from this generator, is an XML format. Of course, we can choose a different type of format, but XML is a very frequently used a metadata record for data encoding in the metadata world. So we will talk a little bit of XML as the basis of some other things we're going to talk about for the rest of this course. So many of you must have heard of HTML. So that is a markup language used for web pages. So basically, the information will be described in the XML format, and there are different tags in HTML files to decide how each piece of information will be displayed. XML can be regarded as a sibling of HTML in the sense that it also uses a lot of the tags, and that they share many similar structure and syntax. However, XML, which stands for Extensible Markup Language, is actually quite different from HTML in the sense that XML is used to store and transport data, but HTML is used to display data. And so XML, the format of XML is used to mark the semantics of the information. So all the data will be stored in XML, and the semantics will be expressed as a text used in XML. And here are two comments I want to make. The first is XML tags can be nested so that we can have different layers of semantics. So some of the tags can belong to another tag over there. For example, we can say that the author may have a first name or last name, but the tags to express first and last names are definitely a part of the overall author name instead of the overall document. And the other thing is XML also uses attributes to add more information to the elements, and we will see more example on the next slide. So yeah, don't worry too much if this does not make sense to you. Yeah, so the other really important thing about XML is that, of course, in a self-designed XML file, for example, if we just want to create an XML file for our own purposes, we can definitely use freely defined tags. But in most of the cases, when we use XML to express metadata under certain metadata standards, those tags used in XML must be predefined by someone else, and mostly defined by the metadata standard. So we can only use those elements that are already over there. Okay, so here are some examples. So XML structure-wise, XML must use a start tag and end tag as a pair to express a statement. So this is something that XML is very differently from HTML, because if you remember, we can actually use a single tag to say, okay, here is the information that we want to display in a specific way. So, but in XML, this structure must be complete so that when this piece of information is processed by someone, this person or machine can know, okay, the boundaries of this statement. This is very important for XML. And within a start and the end tag is a statement, and like I mentioned, so the statement has the element name, which is text, and then in the middle is the content or the value. But of course, here the text element contains some other sub elements, abstract and section. So we can imagine that for the article, so the text tag or element contains all the text related to this article. And of course, the text can include a different type of text. So the abstract text and the text from different sections. And so for the sake of semantics, they are nested under all this different type of text can be nested under the text tag to be more accurately expressing, the data. And within, of course, within each sub element in the abstract. So the abstract itself is the element, and then the value is in order to evolve. Then this text string is a value of this metadata statement. And the other thing is the attribute that I just talked to. So we can assign attributes to the element to add more semantics to the metadata statement. So, for example, we can assign the attribute number to identify the order number of this section. We say this is section 1, and then the section may have a title that is also expressed as attribute. And normally it doesn't really matter if a piece of information is assigned as the attribute or the value. So as long as it makes sense. But of course, in our assignment, we don't need to worry about the attributes because we won't have the chance to use the attribute, but it is often a very useful part of XML. And the last thing is, and actually a very important thing that we won't be able to see from our assignment is the concept of metadata record, because here we can see that the article tag forms some sort of a comprehensive record. And in this record, so this record aims to describe one specific article. And then within this article, within this record, we have multiple statements that form a comprehensive description of the article. And here I want to say this container tag that forms the record is actually critical for an XML document. And in our assignment, so this can be achieved by choosing including root element. So for example, here the metadata tag is a root element, and also going back to the example here, in our slide, the article tag is a root element. This is something we normally want to have. Not normally, we always want to have. And of course, when I described the assignment, I said we don't need to choose it for the sake of this assignment. But when we try to create a real record, we always need to have the root element. So this is something you can think about. Oh, sorry, I don't know why it's wrong. But this is something you need to think about, and I'm not requiring you to have the root element, but I'm just saying that in the real world, so all the XML record before it can be called a record must have this root element for the boundary of this record. So this is another clarification I want to make. So as we compare XML and HTML, so we can see a few major differences. And some of these are what we have already discussed. XML is for storing the content, but HTML is for displaying the content or presenting the content. And we have also mentioned that XML is very frequently used in the data structure. It is highly popular in coding metadata standard, but HTML itself doesn't do much to contain data because it is very weak to validate data. We didn't mention this. We will mention this in the next slide, actually, so don't worry about it. But the one thing I want to stress here is that XML is based on extensible set of tags, and the HTML is based on a fixed set of tags. So in HTML, all the tags are designed for displaying. So each tag will point to a specific style to be displayed in a certain way on a web page. So we can do that through the accompanied CSS file. So CSS file defines, like, for the tag P, everything within this tag will be displayed, for example, in a specific font size and in a specific font color. And so all the tags will be defined in the CSS files. But in XML file, so the tags are not predefined, but we can actually include the tags defined from all the different metadata schemes to form a comprehensive element set to describe some information objects. And to do that, we will need to use this concept called namespace. So if you remember, we have mentioned a namespace earlier in this week. So we have mentioned that we can use the Dublin core itself as a namespace, which are the terminologies defined by Dublin core, and we can actually also use external namespaces. So in XML, namespace is critical for the algorithm to determine the specific meaning of the tag. So we can, of course, always use extensible tags, but the sources of this tags needs to be defined and defined through the namespace. And below is an example. So in this as student tag, so it basically defines, so XML NS means the namespace of XML. And of course, this S will point to a specific namespace defined here. So it is this namespace, spectrafocus.com student. So what it means is that all the following tags that has this prefix of S, for example, as first, as last, and as title, are taken from this taxonomy on the web page of, defined here. So this is how namespace is defined. And by defining all the different namespaces, we can actually keep adding, different tags to the metadata record represented in this XML document. So this is how a very simple specification of how XML works. And so I'm hoping that you can use this assignment to get a first glimpse of an XML record. And we will come back to some of the concepts related to XML because it is a very critical part of metadata world. And for a lot of the other metadata standards that we're going to discuss this week and the next few weeks, they can actually be easily expressed as an XML document. And some of the concepts of XML will also be critical to our understanding of this metadata records. So this is about XML. Now let's go back to Dublin Core. So we have mentioned some of the most basic knowledge of Dublin Core is and also of our assignment, which is to create a Dublin Core record. But I do want to give you a more critical perspective of Dublin Core and how the importance of Dublin Core today. So we have mentioned that Dublin Core is a very popular metadata standards, not just in the library community, but also in archives and museum communities. That said, Dublin Core actually has not been regarded as a very successful metadata standards as well, because it has never reached its the goal that its designers envisioned. That is to be used by the internet. So like what we discussed in the very beginning, the original designing purpose of Dublin Core is to facilitate the retrieval of documents on the internet that was still very new when Dublin Core was designed. And there are a few reasons discussed by BL, I guess that's how this name is pronounced. And he wrote this very popular article, very famous article about the death of Dublin Core in 2004. And please pay attention to the year. That's just 10 years after Dublin Core was developed. And the two reasons he gave, including Dublin Core, is actually offers a too simple data structure. So after dumbing down from all the other sources, the information stored as Dublin Core format in some databases cannot be used to support very advanced searching functions. That's a very big problem of Dublin Core. And the other part is the organization behind Dublin Core. So Dublin Core was initiated by OCLC. So if you go to the website of Dublin Core, I think it's very easy to have the impression that it has a very good documentation, but at the same time, it has a lot of very complex documentation as well, in the sense that there are many pieces of documents containing very similar information. So the organization behind Dublin Core is actually very bureaucratic and complex. So this is very bad for information standards to be developed, to be following the trends that the bigger information environments and how the environment will need this standard. So a lot of these factors contribute to the decreasing usage of Dublin Core, even though it is still used by many projects in the library, archives, and museum world. It has never been used beyond this broader information world. So that is certainly a big problem, Dublin Core, that is regarded to be dead by many people, including this article. But I should also say, even so, Dublin Core is still very successful to certain extents. It is also a very, very easy to use and lightweighted metadata standard. It can be easily mapped to a lot of other metadata standards, And it is, of course, a good example to be used, for demonstration, like in our course, in a very intro course, for you to understand the basic concepts of metadata standards. So those are some of the reasons why, even though I don't think Dublin Core is very popular and broadly used today, I still want to talk about Dublin Core, and I hope you can learn more about these metadata standards because it still has its usage depending on what you are going to do in the future. And of course, Dublin Core has also become various national and international standards, such as NISO standard and the ISO standards, International Standard Organization. So, which makes, Dublin Core a very stable standard that can stay here, and we can use it consistently in the future if we need to. Of course, Dublin Core is just one standard in the family of standards. And last week, we have read a few literature that talks about the diversity of this landscape. And I think it's not very hard to see that there are many metadata standards out there for different purposes. And this is basically a summary of the 4 major categories of metadata standards we have discussed. There is data structure, and we've talked about Dublin Core here, and we'll talk about some others later. And there is data content. RDNA, CR2 are something we are going to talk about next week. And there is a data exchange. They are the encoding and technical standards. And one example is XML. And the last category are data values. They are the classification system or the taxonomies, like a Library of Congress subject heading or a Dewey Decimal classification, something like this. And the point of this graph is not just to show you these names, but also to say that there are a lot of overlaps between all these categories, especially when we talk about individual standards. So a lot of the standards can serve more than one purposes, and we will definitely talk about some of these examples when we talk about those standards used in the library world. But when we look at this graph, when we look at all these different metadata standards, and I hope you have this one question in your mind, which is, do we really need all these standards? And why, people develop all these standards, even though there are already something similar over there? And this could have been one question I will ask your opinion about if we had the synchronous session. But let me say there are many reasons why we want to have all these different, and some are very similar standards, functional similar standards. And one is that there are different requirements for the metadata standards in different communities or for different information objects. For example, we will talk about the different standards used by libraries, archives, and museums, and the digital collections. And of course, we can see the standards are designed for different purposes. That is definitely one of the reasons. But I do want to point to the other reason that sometimes this functional differences doesn't really totally warrant a new standard, but people still develop new standards anyway. And this is very famously summarized into the toothbrush theory. So yeah, I don't know how many of you have seen this comic before. So the title is How Standards Are Proliferated. So first we have a situation. There are already 14 competing standards. And then people will say, oh, we already have so much, that's ridiculous. So we need to develop one universal standard that covers everyone's use cases and cover everyone's functions. So we have this one standard that rules them all. And then after the development, then the situation becomes, now there are 15 competing standards. So this is basically the point between this famous toothbrush theory, which states that everyone agrees that a toothbrush is a good idea, but no one wants to use others. So this is a big problem in the metadata world, that we are doing a lot of repetitive works. And in many cases, one standard is developed with the vision that we want it to be used as broadly as possible. But the reality is that many of these standards cannot go beyond the immediate context in which it is designed. And so this actually points to a lot of important social technical reasons behind the use of metadata and the development of metadata standards. Yeah, I'm trying to include some of this contents in the second half of this course. But here I just want to stress that when we look at a list like this, and when we think about how we should deal with a future metadata needs, whether we will need to use something or whether we will need to develop something, I think reusability is always an important principle when we think about metadata, especially as a designer. I think one of the agreements people have had in the metadata world is that we should try to reuse other people's standards as much as possible, even though it is very hard. So when we design something new, we should only try to design for a very specific needs that no other standard is able to cover. But for those common functions or for those common areas or elements, we should try to reuse others. And we have also mentioned in the XML part of the lecture that in our existing metadata infrastructure, there are a lot of capacities to incorporate the components of different metadata standards into a single task, into a single description or a single document. So this is something we should think about. Reinventing the wheel is expensive and will require a lot of efforts. So in most cases, it's not worth it. So we may want to think about reusing as much as possible. And talking about reusing, I also want to talk a little bit about the FAIR principles. It is a little detour from this course content, but I'm talking about it because I think it's still important to think about these principles when we talk about metadata. I will talk about the connection here, but let me give you a brief introduction to the FAIR principles. So this was proposed in 2016 by a group of scientists. So the idea is that for all the digital assets and the immediate context of FAIR principles are the research data. So now doing research requires an increasingly amount of data, as you may know. So the management of data should have certain principles that we should adhere to. And so such principles are summarized into the 4 major goals of findability, accessibility, interoperability, and reusability. And under these 4 goals, these researchers have proposed 15 principles of how we should manage research data so that they can be fair, or these are 4 goals. And the ultimate goal is that the data can be used by computational systems with none or minimal human intervention. And this is important because when we think about metadata, I think a lot of the purpose of metadata is actually to facilitate this finding and using of these digital assets. So I think metadata definitely should aim to improve fairness of other digital assets. And how best to do that is something we will discuss and think about in the next few weeks. So I do want to mention FAIR principles. You will, if you take any classes in research data management program, you will hear a lot about FAIR principles. But I think it also applies to our class from this perspective. And more importantly, I think it's also important to think about the relationship between metadata and data from another perspective, which is that metadata is a type of data itself. And is metadata fair enough? Is those metadata collection, metadata stored in the information systems findable, accessible, interoperable, and reusable enough? I think that's certainly a evaluation standard that we should use to look at the metadata standards. And I will also try to ask you to examine some of the standards in the next few weeks. And here I want you to take a look at these 15 principles under the 4 goals. So when you watch this video, I strongly encourage you to pause here for like 1 or 2 minutes to read through all these principles. And one of the first things you may notice is that in many of the principles, there is the expression of metadata, or just data, but it doesn't really matter because metadata is a type of data, and we should think about how metadata may contribute to these 4 goals, and at the same time, how metadata should adhere to these 4 goals. And based on the existing empirical research, and I should mention some of this research was conducted by our own Dr. Brian Dobreski. And they tend to show that a lot of the metadata, especially in the traditional library world, are not really findable, accessible, interoperable, or reusable because of the limitations in the metadata standard. So this is something I want you to think about, and this is a very basic framework that I think will apply to a lot of things we will discuss in the next few weeks. So I really hope you to have this perspective. And from the general topic of metadata, let's move to a more specific type of metadata. Those metadata standards dedicated to describing resources. So let me offer a different classification of metadata. So we can say this metadata is classified by the function of standard, what this standard is designed to do. So we have 3 categories: descriptive metadata, or those standards that aim to describe a resource, describe resources for discovery and identification. And we also have administrative metadata. These standards aim to provide information to help manage a resource. So for example, it includes the information related to the creator or ownership of the resource, and maybe who can access it. For example, the copyright of the information objects, etc. And then there is a structural metadata, and I should say structural here means very different from content structure. So it basically means how compound objects are put together. And this is more frequently used in the archival world. So because as we will discuss in the archive in collection, the order of resources, how the collection should be combined together is a very critical attribute of the resources. So we have the three types of metadata, and this section will we will talk about descriptive metadata, and this is also the most important category in terms of the function of metadata. So most of the metadata standards, I would say, are aimed to describe things instead of to offer supports for the management or describe the compound objects. And a description so actually contains two aspects. When we try to describe a resource, there are two major perspectives we can describe these things. The first is the content. So for example, the title or the language or the subject, etc. And then there is a carrier element, such as a format and dimension. And from this perspective, we can argue that if we go back to the other classification system we have discussed, data structure, content, values, and exchange, we can say that both content standards and structure standards can be used to describe things. And so we have discussed a DC as an example of the structural standard. We have mentioned that a DC has these 15 basic metadata elements to describe all the information objects. And of course, it doesn't cover some of the things that content standards will do, like where the information should be taken, but actually both aim to describe information objects. And so there are a few different type of surrogate records. Well, when we look at the discovery tools that includes descriptive metadata, and we will also talk about some of them before the end of this video. So let's look at some of these discovery tools for the discovery metadata. Using the discovery metadata, I should say. So first is bibliographies. I'm sure many of you are very familiar with bibliographies because they are everywhere. For example, in the end of academic books or in the end of any academic paper, there will be a list of bibliographies that are cited in the book and or paper. So basically each bibliography is a list of other information resources, and it can be a part of another information resource, like we mentioned at the end of the book, or it can be its own. So bibliographies can be published by its own as a book itself, to list, some other information resources under certain topics. And it is always following a style or standard for the format of this descriptive data. And you are definitely familiar with many of these standards, APA or MLA or Chicago, etc. And one specific type of bibliographies is a pathfinder. A pathfinder is normally defined as a bibliography to help begin search in a particular topic or subject area. And in reality, a lot of libraries, especially subject librarians, help to create these pathfinders to be used by students, especially when they're new to a specific topic or a research domain. And this is an example of a bibliography. Of course, each record in the bibliography is a descriptive information related to another information object somewhere else. And this record is a piece of metadata record, and the bibliography is a compilation of all these records into a discovery tool. And then we have indexes. So we have mentioned indexes when we talk about information retrieval. We mentioned that it is a tool for users to use queries to find the document that matches the queries, right? And also discovery tool of itself. So indexes actually do the same thing. It helps to the access to the analyzed contents of information resources. And in most cases, indexes are physically separate from the resources they describe. And when we talk about indexes today, especially a lot of those online digital research products, indexes are bundled together by some vendors into this what we call metadata databases like Web of Science or Scopus. Because when we think about Web of Science, it is basically an index of all the publications based on all the different metadata elements. And so a lot of these indexes are proprietary and following standards from the vendors, but they still conform to some common guidelines. We can still use them based on some consistent rules. And this is one example of the index as part of an online database. So we see this descriptive record of this publication. So it includes all the major elements of this publication, including author, title, source, etc. So again, this is a compilation of descriptive information of some information objects and developed into a tool to be used by users to find the information. So after talking about these two categories, I think there are some higher level designing questions when we talk about information description. So we have actually seen quite a lot of this in the Dublin Core standard, that what data elements should be included in a record, and what data elements are used to offer a comprehensive description of information objects. And this question also underlies one of the discussion questions we have this week. So so in question 2, I'm hoping you can reflect for the paper that we try to describe whether the elements available from Dublin-4 are sufficient or not to offer this description. But this is certainly a key role of the structural metadata like Dublin Core to define the most basic metadata elements. But beyond this, we actually have a few other designing questions that are mostly covered by the content standards. The first is the source of information, or where should the data elements come from in the information objects? Should we directly collect it from a specific place in the information object, or should we maybe use some other methods to collect it from, like we can use machine learning methods to extract keywords from, the full text of publications. So, and we can use these keywords to, describe these articles. And that's another potential source of information. And there are some other decisions to be made here. And the other is the format of the data. So how should the data be recorded? We have mentioned, for example, Dublin Core has some recommended data format, but that's really not what Dublin Core was something Dublin Core should require, because it only recommends. But in the content standards, there are also those required format that one needs to follow when he or she creates a format using the standard. And then there is also the level of details of information to be used to describe the information object. To what extent shall the record describe the information object? Shall we include as many details as possible, or just some more general statements? And these are some meta questions that we will see when we talk about different standards or different categories of standards. And given the time, I would say this video will end here. And so this is all the contents we'll talk about in week 6. So in this week, so unfortunately, I'm unable to talk to you online. So we will have an extra assignment that you will need to do, to make up the discussion that we were supposed to have. So please let me know if you have any questions about the course content or the assignment, especially since we cannot talk directly. So I would love to answer all your questions as fast as I can. And otherwise, I definitely look forward to talk to you in person next week. So that's it for this week. Bye.